So for today, we are very lucky to have two subject matter experts to share their knowledge for today's session. From academic, Dr. Amir Fuad Wajdi. Morning, Doctor. How are you?
Hi, morning. Assalamualaikum warahmatullah. Alhamdulillah.
We have TS Nurulhusna Muhamad Kasim. Yes, Nurulhusna, how are you? So, I'm TS Azhar bin Abdul Latif from Medialab Academy will become a moderator for today's sessions. So, for today's program, we are collaborating from M Studio, One City, Subang Jaya. So, as a reminder to all participants, please do register yourself at link given at MS Teams chat box. So this is for e-certificates and CPD purposes. So basically, for today's programs, we will start with the first talk by the first speaker, first for about 30 minutes, and followed by talk by TS Nurulhusna for another 30 minutes. Then we have a Q&A sessions for 15 minutes at the end of the talk. So participants can post questions along the program at the MS Team chat box, but speaker will answer the question at the end of the sessions. So we shall start now. So first talk is by academic speakers, Dr. Amir Fuad Wajdi Othman, Senior Lecturer, School of Electrical and Electronics Engineering, Universiti of Sains Malaysia, USM. Dr. Amir received his Bachelor of Engineering from Toyohashi University of Technology, Japan, and Master of Engineering from University of Manchester Institute of Science and Technology, and PhD from Sheffield Hallam University, UK. Dr. Amir expertise in swarm robotics, artificial intelligence, and cybernetics systems. So without further delay, we'd like to invite Dr. Amir.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi and very good morning. Okay, can you see my slides? Boleh? Boleh nampak?
Ya, boleh.
Okay, terima kasih. First of all, terima kasih kepada Tuan Pengerusi. Thank you for Mr. Chairperson and Medialab and board. Bismillahirrahmanirrahim. Alhamdulillah Rabbil Alamin. The first topic for today's talk will be entitled Development of Pole Climbing Robot, which will be delivered by me, Amir Fuad Wajdi bin Othman. I am currently with University Sains of Malaysia, School of Electrical and Electronics Engineering. My research interests, I have two or three research interests. The most actually, I'm focusing on the swarm intelligence up until now. The mobile robotics, I turned my interest into mobile robotics since 2015, 2016. And the artificial intelligence also one of my research interests, one of my topics. So as introduced by Mr. Chairperson just now, I received my engineering, BH in mechatronic engineering from Japan, master degree in UMIS Manchester, and last but not least, the PhD degree in Sheffield Hallam University in the UK. So this is a safety briefing. As you might know, like in the event of emergency, please leave your room, your house in orderly fashion, follow the exit sign, and also be at the emergency assembly point. So the flow for the talk today, first I'll introduce, give the introduction, what is the pole climbing robot, and then give the motivations of why me and my team focusing on this pole climbing robots, and then we introduce some of the climbing robots that we develop in-house, and we draw the conclusions. So the scope for this talk and the scope of for this talk for the robots introduction is for the introduction of the robots limited to the one that we have in-house, we develop in-house. So the introduction, as you might know, the robot, right? The robot. Most of all, when we say robot, then we imagine, then we can see, we picture the robot as a mechanical agent. But currently, until recently, for the last 10 years, when we say robot, it also include the virtual artificial agent. So these virtual artificial agents is in another field, what we call as a swarm engineering or swarm robotics. Usually for the swarm robotics, we refer the robot itself is referred as a virtual artificial agent. But for this talk, is pole climbing robot is we are focusing on the mechanical or physical embodiment robot. Yeah. So the material used to fabricate a robot is also one of the important things that is needed to be considered. Most of the work done in our lab, we are using the what we call it the recycle board, and some of it we use the straw board. We just want to show the concept, right, to prove the concept. So the climbing robots highlighted in many challenges which you can identify. For example, to identify the most suitable locomotion, gerakan yang paling sesuai, the required robot configuration, and also the design, safe and reliable addition. So safe and reliable addition is most important thing when we dealing with this climbing robot. So reliable addition also means the gripping factor of the robot onto the pole. So the first motivations, for example, every day when we leave our house in the morning, first thing we can see is this pole. Okay, the pole. The pole is a tiang. In Malay, we call it tiang. So the pole can be for the distribution, power distribution line, also can be the communications line. So on the pole, where we have the junction boxes for the telecom lines, and also we have the transformer for power distribution lines. So cleaning the poles, usually it takes some time. Sometimes, why do we need to venture in this pole climbing? First of all, we can use the robot to do the cleaning, for example, and also to do the maintenance on the pole. So first thing first, when we get the robot and we fit it with the camera and let the robot climb up, and we can do the maintenance or do the inspection. Okay. The second motivations, why did we venture into these pole climbing robots? As it has big potential in the agriculture. For example, you can use it as a harvesting, for example, harvesting the coconut, and you can use as the trimming. We call it a trimming for tree maintenance, and also we can use as a observation for tree-dwelling animals such as the cuckoo birds or the tupai, the squirrel. Another motivations for us venturing into this is that, as we know, Malaysia, we have lots of the Aquilaria trees, or in Kelantan we call it as a pokok depu, which needs to be inoculated. Okay, so this Aquilaria tree needs to be drilled into the tree, and we have to inoculate the fungal to induce the agar wood and which can be sold to the market lah. So if I'm not mistaken, based on my reading, one whole tree after the inoculation, after 7 years, between 7 to 10 years, one tree will be worth about 10,000 ringgit. So it depends on the inoculation process lah. Okay. So the third motivation is, for example, there's lots of manufacturing sites which have the high-rise ataupun high risk areas which make difficult for inspection tasks to do lah. So climbing to the high risk area might of course might instigate the danger to the maintenance personnel. And in some areas where the piping is too packed for human inspection, then this kind of robot can be used into the it can bring into the manufacturing sites. Benchmark. Okay, according to Tavakoli, in 2008, Tavakoli proposed the benchmark where you can evaluate the pole climbing robot. For example, first to evaluate, when we have to itemize what evaluation method that we want to use. For example, they propose, for example, the fulfillment of the mission, the robot can climb over one structure to another and get a 30 marks. And also you can evaluate the quality of a performance. So it's stated here, it shows here 10 defected welding should be recognized as the position should be registered. Nevertheless, this is the benchmark for robot climbing competition in the US, if I'm not mistaken. So even though its device ataupun is proposed this benchmark for the competition, but we in the researchers still can use it, and we can devise it on based on our needs. That's the benchmark where we can evaluate our own robots and we give our score. So the types of the robot. So the types of the robot, pole climbing robot can be categorized in many terms. Okay, for example, the locomotion techniques, the gripping techniques. So if we say the gripping, if we want to categorize it in the gripping technique, then it can be under, for example, the claw, the suction, the pressure. Okay, the second terms or the category can be locomotion. The locomotion can be the wheelbase, linear actuator, and so on and so forth. Okay, so according to Lau, the specification, Lau et al. Specified the characteristic on the different mechanism. So it characterized based on the mechanism. For example, Lau characterize it in 5 different mechanisms. The first one, wheel mechanism. The second is the piston mechanism, where he used the piston movement to get the locomotion for the robot. The third one is the self-locking rolling, which combine the self-locking rolling, which can be combined to the piston mechanism, the serial, and also the modular. Based on that, we can categorize it into the complexity of the system, the flexibility, the stability, so on and so forth. So the objective. So the objective of this work, first, when we want to, we just throw in other idea. We have to design and fabricate and prototype a pole climbing robot that can climb out and down a pole. So this pole or pole like tree, when we throw this question with this problem to anyone, first thing comes into picture to their mind is something, the robot similar to the koala bear, for example, or the monkey and other and inchworm, because we are living with this nature, right? So first thing, we picture this. We picture the pole climbing robot must be similar, something that has the locomotion style or the gripping style, such as the monkey ataupun or the biological punya influence lah. Okay, so that's the first. Then we throw the second objective. This robot can be autonomous or semi-autonomous, and it will be added. It will be added feature if we can add this human machine interface. So it's similar to us. when we want to when we are designing the pole climbing robot first, because we only see this without we doing this the first two, okay, the first two project we done this without doing the survey. We as a our team lah, we give this and we give this project, we give this title to student and come up with this idea. So the first one is what we call it as a simple pole climbing robot. The simple pole climbing robot is because it comes from the inspiration from the koala bear and also the monkey, but then we only have two grippers. Okay, so we design the grippers. All this design is done, is drawn using the CAD, AutoCAD, and we printed on by using the 3D printer. So this first simple pole climbing robot comes with two grippers, two motors, and one linear motor or one linear actuator. Okay, so this and also we are using, of course, when we are dealing with motors, then we need to use the motor driver. This motor driver to prevent the back EMF or back current from the motor to destroy our the Arduino, okay, microcontroller. So that's our first design. So the first design how this robot is moving up is following the sequence, because we have two grippers and we start with start position with the gripper close, and we release the upper gripper and we move the linear actuator at the max position, we extend it, and then we grip it again, the upper gripper closes again, and we open the lower gripper and we retract the linear actuator at the minimum position, and then it closes. And same goes how the climbing down sequence is the reverse of the climbing up. So this is the robot. Okay, so we tested the robot and we tested the actual actuator in speed in the percentage. This actuator speed percentage reflecting or referring to the PWM power, PWM with modulation. It's 100%, 75%, and 50%. Of course, if we give the 100%, the actuator speed will become quicker, and the time taken also will become shorter. So the second robot is the inchworm inspired pole climbing robot. So this inchworm inspired pole climbing robot, where we have similar to the first one, we have two grippers, but this time this gripper we get it the off-shelf ataupun is available on the market lah. So we bought these two grippers and then we fit it onto the acrylic pieces as the robot body, and each gripper connected with the servo motor, and at each joint we have the servo motor. So we have three joints, 1, 2, 3, and 2 grippers. So overall we have 5 servo motor. So this, if I'm not mistaken, less than the weight is less than 300 gram. Okay. So we tested and it shows that is this is the robot during the trash, and this is the extent. Okay. So it's similar to the previous motion just now. We just we play with the gripping, releasing, and gripping the gripper. Okay. Next, we introduce. Okay, from now on, the wheel-based climber. We have 3 projects on the wheel-based climber. These 3 projects afterwards is unpublished. Okay, unpublished. But then is the paper is already there, is under review lah. So the first is where we call it as the one driving wheel. So at this robot, we use one driving wheel, and we use the pneumatic clamping. the pneumatic cylinders to push this wheel, okay, this wheel to onto the pole. Okay, so when the robot is in action, the pneumatic cylinder, we have these pneumatic cylinders, two of it, okay, one on the left and then one on the right, and we have the blue wheel. The blue wheel is the driving wheel. This driving wheel, when we turn the driving wheel, the robot wheel goes up and down. So the pneumatic cylinders are configured in the way that the clamp will be normally extended. So that means that it will always clamp to the tree or to the pole. When we want to release it, then we have to give the current to the solenoid such that it will release or it will retract the cylinders. So this robot made up from the aluminum profile. We cut it and we screw it together lah. So this demo for the robot. It shows that the robot now is climbing up. The robot weight is total weight is currently as 3.6 kilogram, and the gas pressure for the clamper or for the pneumatic cylinder is must be more than 2.8 bar. This is the result for the first one driving wheel. The second robot, which using the wheels, we use the two driving wheels, and we design it and we fabricate it using the straw board or cardboard. Okay, so this was done during the first PKP, the second PKP. So we cannot go out, and most of the hardware store are closed. So we want to prove the concept, and we build it using the what available at hand. So we are using two wheels, two motors, and the body of the robot are cardboard. Okay, so this is a minimalist. This is a circuit diagram, and we built two robots, robot A and robot B. Robot B can be seen quicker because of the structure is much stiffer to the robot A, which can reduce the slipping. And the third one, where we use three driving wheels for locomotion. So it can be used for inspection purpose. Can be mounted camera. It can be mounted camera or phone for the live streaming. And again, this was done during the PKP. Yeah. So the robot frame is also made up from the cardboard. Okay. This is the circuit diagram of the robot, and this special about this robot where we combine it with the human machine interface. So we add the Bluetooth. By using Bluetooth and the smartphone, we can connect to the robot, and we can control the motion up and down. So first, it can start testing the Bluetooth. If it has the Bluetooth connected, then it check whether what signal are we passing to the robot. If it's we give the signal number 1, then it means that the robot must climb up, and it will loop here until we end until we change the input to the Bluetooth. Okay. If you press 2, then it's moving down. If press 0, then it stop. Okay. And this is the interface up and down button, and the robot is still in motion. So here's some short demo for the robot. First, we insert the battery. Insert the battery because we don't have the switch in hand. Okay. And then this is showing the overall robot design. And we have the infrared there, the sensor. This is the overall design of the robot. Then we connect to the Bluetooth just now. Okay. And we give the, if we press one, it goes up. Okay. So the stop, press stop button to stop. And then we press the down button, down arrow, then the wheels will rotate downwards. Okay. So here is the robot, the demo of the robot on a, this is PVC pole lah, okay, the PVC pipe. So that's the result of the 3 wheels driving robot just now. And last but not least, this is our latest model, which was developed in house, and we developed it using the aluminum profile. So this robot carries, the total weight of the robot is about 13 kilogram in weight, and we use aluminum profile for the frame because from our experiment and yeah, from our test and our experiment, we have to have this stiff ataupun the strong frame lah for a robot. Okay, so we have tested this robot on the pole, but unfortunately we don't have the video while we are trying, or we are climbing, or we did the experiment on the pole. But then it shows here the robot is not tested on the tree. Okay. On the pole, the robot can move upward and downward smoothly, but on the pole-like tree, we can see the slipping. This is because of the surface of the tree ataupun the shape of the tree is not even as a pole, right? So, okay. So for this robot, we make it at modular. So what you are seeing here is this is the climbing module. The climbing module will be, the climbing module will be on the bottom. Okay. Then above the climbing module, it can be fitted with any other module lah. It can be camera, it can be the drill. For in our case here, we have built this robot and we fitted with the drill function such that it will drill the pole, the tree, the acularia, the tree, to help the farmer to drill their tree before the inoculations. Okay. So the challenges, what is the most challenge is that the robot keeps slipping, and also the robot will fail easily when the torque or the force is unbalanced. It means that kalau the torque, the tekanan, the torque of the motor is unbalanced. Currently, we are, as you've seen just now, we have 2 wheels or 3 wheels. If the torque of the motor is unbalanced, then it start to slip. Okay. So the future work and the future direction to tackle the problem, maybe we ourselves can introduce a self-locking mechanism such that the robot won't slip. And for the 2 wheels robot and 3 wheels robot, just now we use the cardboard, and probably we can change to the more stiffer ataupun more stronger frame by using the mild steel ataupun aluminium frame. So the wheel also can be changed to bigger such that it will have more contact on the pole and more friction to prevent slipping. And later, the last but not least, we can introduce a camera module and can make the pole climbing robot more versatile. It can be used as a surveillance ataupun for the traffic, whatever it is can be used lah. So I think that's it for me. Okay, thank you. If you have any queries, you can contact me on this email. Okay, terima kasih.
Okay, thank you, Dr. Amir, for the talk. So, participants, please do remind to fill up your attendance form for today's sessions, so for us records. So, the attendance should be available at checkboarding. So, okay, this form, fill up your name as per your actual name that you want to your research. So, thanks again to Amir for the knowledge sharings. So next, we'd like to invite the second speaker, T.S. Nurulhusna, Muhamad Kasim, Principal Assistant Director from Jabatan Penyiaran Malaysia RTM. T.S. Nurulhusna has been with RTM since year 2004, around 17 years. And she obtained Bachelor of Engineering from Universiti of Malaysia. And then further her study Master of Engineering from University of New South Wales, Australia. So for today, T.S. Nurulhusna will sharing the topics on digital radio. So without further delay, please do invite T.S. Nurulhusna. Muhamad Kasim.
Okay, Assalamualaikum and a very good morning to Mr. Chairman T.S. Azhar. So before I start, I want to test my voice and also the video. Is it clear, everybody?
Clear.
Okay, so I will share my slides. Okay, so are you guys ready to move to digital radio?
Okay.
Okay, next. A short introduction about myself. I get my formal education, my first degree in Bachelor in Engineering, Communication and Computer Engineering in UKM. And I got my Master in Engineering, Master of Engineering Science in Telecommunication at University of New South Wales, Australia. Now serve in Public Service Department at Jabatan Penyiaran Malaysia RTM as a Principal Assistant Director in Audio Unit, and have a working experience at a private sector for 3 years. So main function to operate and maintain TTNC station, which is our first micro satellite, which is TungSat-1 by Astronautic Technology Sdn Bhd, and have 17 years of experience in public service radio. And also my external participation in World DAB Asia Pacific Technical Group. Okay, so for today's webinar, the flow of my thoughts, starting from the Malaysian radio landscape, digital radio introductory, radio transmission and distribution, then ecosystem readiness, and lastly, conclusion and recommendation. So before we go, we go to the Malaysian radio landscape. Malaysia has a radio market with multiple players and service in different language. So RTM as public service broadcaster has a total number of 34 stations, which comprise of 6 national stations in 5 languages, 14 regional radio at state level, and 14 local radio. While for Commercial Radio Malaysia have 25 members, dominated by Astro Radio and Media Prima, but growing number of independents. From JFK Radio Audience Measurement Survey with Fuad in 2021, revealed that 94% of individuals in Peninsular Malaysia, equivalent to 20.6 million weekly radio listeners, increasing by 282,000. So it shows that radio continues to be a strong and effective advertising channel for business. It is broadcast medium that can be accessed anywhere, anytime by anybody. The engaging and social nature of radio and its powerful connection with its audience makes radio the perfect way to build brand awareness and stimulate digital activity. Okay, next. Before we move further, let's warm up a bit. So this is a simple quiz testing your general knowledge about radio. So those top 3 of the podium can claim present from me later. Okay. So with that, let's start. Okay. It takes longer than usual. Okay. Why? Okay, maybe there's a technical issue here. Okay, it's okay. So let's move to the next slides. Okay. So what is digital radio? So in basic form, digital radio is an application of the technology in which sound is processed and transmitted as stream of binary digits. Digital radio has clearer reception and better sound quality than AM and FM. It can also provide on-screen information such as song and artist information, weather forecasts and news headlines, and the ability to pause and rewind. Digital radio is not internet radio. Internet radio uses a stream of data received through an internet connection via a computer, mobile device, or an internet-enabled radio. This can attract a streaming cost depending on our internet plan. Okay. At the same time, digital development are drawing together the broadcasting, telecommunication, and computer industries in a process of conversion. For all broadcasters, this is leading to a new and challenging business environment. Okay, so generation and reception of digital signal DAB. So on the generation side, each service signal is coded individually at source level, error protected, and time interleaved in the channel coder. The services are then multiplexed Hello.
Okay, I think we have some technical issue
freezing
from Nurulhusna. So we wait for the internet connection to come back.
So is it okay?
Now back. You are back. Just now, I think around few seconds you are disconnected. Yes, Nurulhusna.
Okay. So we go
Okay.
back to the previous.
Okay.
Okay, on the reception. Okay. So on the reception side, DAB ensemble selected in the analog tuner. The digitized output of which is fed to the FDM demodulator and channel decoder to eliminate transmission errors. And the information contained in the FIC is passed to the user interface for service selection and issues to set the frequency appropriately. The MSC data is further processed in an audio decoder to produce the left and right audio signal or in data decoder as appropriate. Okay, next. So there are three major digital audio broadcasting standards to choose from, which the first one is DAB or DAB+. So DAB or DAB+ is an open standard like DRM, works in liberated analog TV band 3, giving more space on multiplexers to stations that want to cover and compete in the same area, like very congested cities, for example, like Kuala Lumpur. And for DRM, the latest digital radio standard can be deployed in all the frequency band, which is AM as well as FM. And this means it can give more content with lower power consumption and better audio quality in FM, but very clearly in AM. And using the current analog frequencies in use. And lastly, for HD radio, is a United States-based proprietary in-band solution, mainly designed for the FM band, and it meets US requirement and uses a generous spectrum allocation. Nowadays, its owners are also promoting a digital-only medium wave solution. And all those three using OFDM type of modulation. Three standards, three sets of technical specification that compete and in some cases complement each other. Okay, next. Why digital radio? Just as was true for other media, the conversion to digital offers radio a wealth of benefit not available from current AM or FM analog system. And radio is an audio services. So consumers naturally compare it to meet the most pervasive high quality audio technology, which is the compact disc or CD. So a good FM signal played by a high quality stationary receiver compares favorably to a CD sounds. But put the FM receiver in a moving vehicle, typical for radio listening, and channel imperfection experienced by FM quickly lower the sound quality. The problem include environmental noise and RF signal reflection that give rise to multipass fading, variation in RF signal due to signal reflection. So the improved robustness of digital radio promise to remedy this and delivering near CD sound for most listening condition. So the development of digital radio has led to improved spectrum efficiency, more channel capacity, or a combination of these benefits. And furthermore, digital radio brings opportunity to extend brands, launch new services, grow audiences and revenues. Okay, so a little bit on the Malaysia digital radio trial journey. RTM has taken up many efforts to study and familiarize the DAB+ system and gain relevant experience and confidence with the DAB+ technology before implementation. So it started since 2009 until 2014. So the first trial is conducted with Telecom Malaysia for field strength measurements, and in February 2030 we did an industrial collaboration trial with the private broadcaster as well, and during February to March 2014 there's a DAB Plus workshop held in Kuala Lumpur, organized by RTM, ABU, and also World DMB. There are 130 participants, include local and international. Okay, this is the head-end equipment located in IBC building RTM. So this is the general DAB system that we use for the trial. So the audio encoder numbers, it depends on the number of programs that we want to test. So, okay. So we use the Menara KL as our main DAB Plus transmitter for 1 kilowatt. And for transposer site, we select 5 locations, which is RTM Kelang, Bukit Lanjan, Bukit Sungai Besi, RTM Kajang, and also KLIA. Okay. Okay, this picture is the coverage for main transmitter sites coverage, and also 5 transposer sites. So this is the measurement equipments that we use, and also the receivers. And this is the few pictures taken during the DAB workshop. And the result, so for coverage zone in the urban and mobile reception, the signal of field strength must exceed 60 dB microvolt per meter. And for suburban and mobile receptions, the field strength should be more than 55 dB microvolt per meter. And for mobile reception, it is need to be more than 50 dB microvolt per meter. So for sound quality, full stereo at 64 kilobit is better than parametric stereo at 16 to 48 kilobit. And the speed test shows that it can still receive good signal at 110 kilometer per hour. And for receiving text and images, we are able to receive a station ID, song titles, and image. A small size image, which is 320 times 640 pixels. However, slides of images taking a longer time to change, between 20 to 50 seconds. Or on the radio transmission. Okay. This is a snapshot how the DAB+, DRM, and also FM transmission differs from each other. FM, for example, is a single carrier network and has a radio data system at 1.2 kilobit per second. So there's a typing error. Instead of a comma, it is 87.5. Okay. So for DAB and DRM, it is a multi-carrier signal network, and it has for DAB+, the channel bandwidth is 1.5 megahertz, while for DRM+ is 96 kilohertz. And it has a flexible data rate for program associated and non-program associated data rates, and both are in FDM modulations. Okay. So this is similar to the previous slide. So FM is a single carrier network. So it shows how DAB can carry multiple audio into single transport stream. Okay. This is the comparison on the cost efficiency of FM, DAB+, and DRM+. It's clearly see that DAB+ and HD radio and also DRM's much more better options, because if you want to carry 18 audio program, you need 18 FM transmitter and also 18 frequencies, a set of 18. So while if you are using the DAB+, so only one, you need only one transmitter to carry 18 program. So it's a lot of saving here. So similar to the HD radio, So it needs 5 transmitter to carry 18 programs, while the DRM Plus, it needs 3 transmitter to carry 18 programs. Okay, for transmission RF power for DAB Plus versus FM. So DAB Plus using 10 times less RF power for same coverage as FM. Okay, due to higher loss in band 3 in the filter and also in the RF line, the effective transmitter power of DAB Plus is quarter to FM. Okay, we go to radio distribution. So radio distribution cost. There are several technologies available for the delivery of radio program content. And there have been several studies on the cost efficiency of broadcast versus other technologies to provide content to mass audiences. Most of these focus on technical costs of operating distribution system, but we must also remember that it is the duty of broadcaster to provide content or coverage to all listeners in the prescribed coverage area. So, okay. So for radio distribution cost analysis, so the above chart shows the operational expenditure for each distribution technology per single radio station. It is immediately visible that with the current data, FM OPEX is the highest, followed by exclusive internet delivery and the realistic case for DAB. While the difference between FM and DAB is largely explained by peculiarity of digital transmission via multiplexers, it is interesting to notice that the exclusive distribution via broadband looks cheaper than FM but still much more expensive than DAB. It is, however, necessary to put the different technologies in perspective. Traditional terrestrial broadcasting provide a 24/7 service whether the audience is actively listening or not, while internet distribution is very susceptible to changes in listening habit. So the figure provided here is based on distribution costs associated with 70 minutes of online listening per day per citizen. But the real expense could either increase or decrease dramatically according to the popularity of the radio station, making it practically impossible to forecast yearly expenses. While this would not overly affect large broadcasters with a national footprint, it could very well endanger smaller entities such as local broadcasters serving communities with longer listening time per citizen than the national system. Than the national station. DAB is the cheapest technology among the three, and interestingly, in the case of a full multiplex, DAB operational expenditure matches the cost of internet distribution in the realistic case. When the three technologies are combined, it is also possible to weigh the relative cost of each compared to the total listening time. Okay, the following figure considers the realistic case of a national radio station simulcasting on FM and DAB station at the same time distributing their content online. So this is a simulcast operation which account for 10% of their daily listening times. Okay, for radio listening scenarios, as shown in the table, terrestrial broadcasting, which is FM and DAB, is available indoors and in the car, but usage might be restricted on the move since the only devices currently having access to terrestrial broadcasting are portable radio sets. Wi-Fi allows internet radio listening only indoors, while mobile broadband permits internet radio listening in all three use cases considered. So being able to access radio not only requires having the right device matching the right technology, but also means having the legal right to consume the contents. Okay, but Malaysia, the lessons, we don't need pay extra lessons to view the content. But some countries, we need extra lesson. Okay, and they need to sign up for additional subscription for the Wi-Fi and also for mobile broadband subscription. Okay, for digital radio ecosystem readiness. So just let's sit back and relax and enjoy this marketing video from World DAB on digital radio. Okay.
The marketing session of this year's World DAB General Assembly.
Is the video okay?
Yeah. It's playing. Tak ada sound ni. Just Nurulhusna.
There's no sound.
Tak ada sound.
Maybe can reshare back. Then include sound.
Share back. Okay. Now?
Yeah, now ada.
Digitization.
Okay. Wait a minute.
Welcome to the marketing session of this year's World DAB General Assembly.
Radio touches the hearts of millions of people. It is the most reliable source of information. It makes you laugh, sing along when nobody's listening, and gives a good vibe.
In these COVID times, radio serves as a friend, helping people feel less lonely and instead be part of their community. Listening hours have gone up all over Europe. Digitization is one of the most important drivers for radio to be relevant and vibrant, regardless of its age as a medium. At home, internet delivers easy access to radio in all its forms, from live radio to podcasts. Competition in the online environment is strong, but keeping radio's high share of listening is a challenge that we as radio broadcasters embrace. DAB+, the digital broadcast ecosystem, offers listeners easy access to more stations than they had on FM, in digital quality, and with better reception throughout the country and/or region. The only competition in this ecosystem is made up of other radio stations. As reflected in figures throughout Europe, DAB+ listening keeps the GRP sales model alive, while CPN income models are in development.
DAB+ is the perfect technique to listen to radio on the move, but it also offers great ease and comfort in the home. The combination of DAB+ and IP offers the best radio experience for listeners, and as we will discuss in the automotive session, the importance of metadata is also crucial in providing a richer experience for the driver. DAB+ has been embraced throughout Europe, and DAB+ networks are continuously being built across the continent. Different countries are at different rollout stages, but with one common goal: DAB+ as the broadcast backbone for listeners.
So, it's the listeners that need to know about the advantages of DAB+. Seduce them to switch from FM to its successor, DAB+. Collaboration is key for a successful introduction and integration of DAB+. You've probably heard about the 5 C's before: coverage, content, consumer devices, cars, and communication. In this session, we take a closer look at the C of communication. The whole chain is involved, and the goal is to generate growth of DAB+ amongst the various stakeholders, bringing DAB Plus to life by providing the right knowledge, attitude and behavior through large public campaigns. Public and private broadcasters are the main drivers for this in their respective countries. They commit to yearly contributions in out-of-pocket, euros, as well as airtime, radio, social media, TV and/or print and outdoor, and make sure that the local digital radio teams collaborate with manufacturers, retail, e-tail and the auto industry. Great campaign ideas bring DAB Plus to life and make the switch from analog listening to digital appealing for listeners. It all starts with the DAB Plus logo and toolkit, free to use via the World DAB website. It offers a complete solution and suggestions for cross-media activities in your market. Most countries develop their campaigns together with advertising agencies. See the session with Schultz and Friends about DAB Plus from an agency perspective. In the Netherlands, we work with a marketing team consisting of creative employees from both public and commercial broadcasters. This team of champions developed our campaign.
The music and scripts were produced by us, and the production of the various versions was done by different audio producers. More than 60 channels joined this campaign, and the most famous DJs and radio presenters are embodying the switch from FM to DAB+, turning them and everyone else involved into ambassadors for DAB+. As a result, DAB+ listening went up with 27% since the launch of the campaign until August this year. In Flanders, advertising agency De Vloer has developed a campaign commissioned by the collaborative partners VRT, Mediahuis and DPG Media, focusing on the advantages of DAB+ on the move. The joint partners developed a DAB+ explainer for listeners. This explainer can easily be adopted by other countries and is great material for a DAB+ website. It is also important to see how DAB+ radios are being presented on the shelves. This example from Van den Borre in Belgium shows how it can be done.
By making sure that campaign periods throughout the year are well communicated to retailers, manufacturers and other partners, you make sure that DAB+ is attractive for listeners from different perspectives at the same time. DAB+ TV ads, radio ads, great look and feel both online and in stores, availability of digital radios, phase out availability of FM only radios, digital newsletters from retailers and e-tailers, playful actions, etc.
Pour encore plus de bonnes ondes, un choix de stations qui donne le tournis et des programmes qui vous suivent plus loin. Plus de stations, plus de sons, plus de radio. DAB+.
Experience taught us that consistency and persistency in communication are necessary to switch from analog listening to digital listening. A DAB+ website is indispensable. For example, Germany has developed a structured, clear and intuitive and modular website. Lots of information relevant to listeners, as retailers and press is available. Take a look if you have the time. It's inspiring. Every country is important. Collaboration and sharing amongst the countries too. Good luck in optimizing your country's collaboration and initiating or expanding your public campaigns. If you need help, please feel free to contact the project office of World DAB. We will be happy to help you.
Okay. So next. So there are few possible strategies for make sure that the rollout for the digital radio is successful. So the first one is platform adoption, while mobile option remain niche, and establish a collaboration between public service media and also a commercial radio network together with industry supports, retailers and manufacturers, and commitment from the governments, and legislation to ensure wide-scale and early fitment of DAB car receivers as standard. So this one, the Ministry of Communication have to work with Minister of Transportations in Gubal 1 of the National Automotive Policies that includes this legislation, and coordinating with neighboring countries in terms of knowledge and expertise. So this is working with automotive, how we can collaborate and bring together the broadcast and automotive industries to ensure the best possible DAB+ digital radio experience for the listener. Okay. Okay, last two slides, recommendation and conclusions. So without financial viability, no academic case for digital radio without FM switch off. So likely need for a government support, and RTM prefer to adopt the DAB standard and also for DRM because it's a low risk in terms of well-proven technology, and it will alleviate FM congestion in an urban area and allow public service media to maintain audience share in face of new media competitions. Okay, the conclusion for today's, there are 5 C's that digital radio needs if it's to success, which is coverage, content, cost, collaboration, and also communication. So for radio broadcasters, the way forward could be a transition to DAB, exploiting internet connectivity to provide additional low data services that enables interactivity with the audience. And RTM, welcoming any activities from the industries. So if any of the participants are interested in joining the digital radio trial, so we are welcome you. And especially there are lots of research need to be done, especially in the technical business case and also cost analysis for the rollout strategies and also for the receiver testing, especially for the automotive sites and for the hybrid radio. So this is a quote by Barry Vaynerchuk. The one who act early and provide real value are destined to succeed. So if you guys have anything to collaborate or any questions, so you just scan the QR codes. There's my email there. So with that, I thank you.
Okay, thank you, Tia Nurulhusna, for the talks and the knowledge sharing. So for the next one, we would like to open the Q&A sessions to all speakers. Participants can ask questions directly. Maybe we can start with the questions that coming from the chat. From TS Muhammad Fauzi to Dr. Wan Amir. Berkaitan robot TV, adalah penggunaan robot ini telah diperluaskan penggunaannya. Bagaimana tak mengetahui kesesuaian robot tersebut untuk industri? So, komen daripada ni Dr. Wan Amir.
Okay, terima kasih Tuan Pengerusi. Berkenaan dengan penggunaan robot, adakah dia telah digunakan secara meluas? Mengikut limited knowledge of mine, limited knowledge, ada satu negara di Europe menggunakannya untuk inspection of this transmission lines. Okay, power distribution line, sorry. Okay. And then some of it are used in India for the harvesting of coconut harvesting. Nak kata secara meluas, it's not that secara meluas because it's kebanyakan di India ni adalah we develop robot, they develop robot like us in Malaysia pun kita buat macam tu juga. We develop robot, kalau di India dia develop robot at their garage lah lebih kurang. But in Malaysia ni, we develop robot from the university and then we propose. But then because of this the idea, because of the idea, the IP semua tu, benda tak boleh pergi jauh. So dia sini setakat tu saja dia boleh pergi. And then kesesuaian robot, macam mana kita nak ketahui adakah dia sesuai. So usually bila kita buat robot ni adalah based on the application specific lah. So we design robot based on their specific application. So for example, what I'm showing just now is about the pole climbing robot. So we just develop and we show that this the pole climbing robot which can be modular. Modular maksud dia kita cuma buat base dia and then it can be modular, boleh tambah apa saja yang nak, apa saja yang kita perlukan untuk industri ataupun researcher from other groups or other university kalau nak guna, then they can add camera, they can add robotics arm, semua tu adalah bukanlah we at the university currently kebanyakan projek yang ini adalah we use term of term copyleft. Copyleft ni maksud dia siapa-siapa dia minta, then we can give the drawing, then you can use on their own lah. Okay, itu saja daripada saya.
Okay, terima kasih Dr. Wan Amir. So hopefully menjawablah pada soalan. Jadi Dr. Wan Amir pun dah offer lah siapa nak collaborate dengan dia, and whoever ada projects can come to them lah, to even to school of electrical electronics USM. Sekiranya perlu ada collaboration. Maybe kita boleh buat panjat tiang telco ke, sebab dalam grup ni ramai yang daripada telecommunication. So if interested, maybe boleh contact Dr. Amir directly. By the way, selain pada tu, whatever yang kita talk hari ni is recorded, dan siapa yang terlepas kita akan hantar semula link untuk replay balik lah. Jadi boleh tengok macam mana apa-apa siapa yang terlepas pembentangan tadi, whoever yang ni terlepas kita boleh watch balik. Jadi yang untuk soalan seterusnya, maybe saya nak tanya pada ni TS Nurulhusna daripada ada few questions berkenaan ditanya antena, daripada berkenaan antena ya Puan. Adakah antena tu sama untuk ni? What is antenna is used from TC Saiful Rezan. Dan daripada TS Muhammad Fauzi, DAB is fully used network. Dan ada beberapa soalan lah daripada TS Muhammad Fauzi lagi berkenaan dengan radio digital telah dilaksanakan meluas ataupun adakah akan tamat siaran radio analog sebagaimana siaran TV. Maybe boleh Ustaz boleh ni jawab soalan ni. Mute. TS kena on mic.
So the first one is about the antenna, right? So
yes,
so ia bergantung kepada frekuensi yang kita guna. So DAB using the band 3 punya band 3. So the antenna also must be operating in the same frequency band in order for the transmitter sides. So on the receiving side, so we must use the suitable antenna also. Okay. And the second question for DAB, fully guna network. So maybe TS Muhammad Fauzi can elaborate more on that. What do you mean by fully use the network? And what is the third question, TS Asa? I can't find. Oh, I can't hear your voice. Tak ada sound. Masih tak dengar, Datuk Azaza.
Okey, sekiranya radio digital dilaksanakan secara meluas, adakah pihak kerajaan akan tamatkan analog lah, radio analog? I mean analog switchover.
Okay, so kita takkan kalau ikutkanlah pelaksanaan digital radio ni, so dia mungkin akan ada fasa simulcast lah, sebab kita tak nak sebab ada yang country yang melaksanakan terus dia tutup FM switch off dan tapi kita akan ada kesan dia lah kalau kita punya orang kata apa, the ecosystem tak ready, so the receiver pun tak ready, so kita akan ada orang kata apa, akan ada complain lah daripada audience nanti, so tak receive. So kita, in order for us kalau nak buat fully switch off for the FM, so kita kena make sure the ecosystem tadilah yang kita cakap tadi, the car semua dah ready. So kalau kita tak ready, so we need to do a simulcast, which means we have to continue transmitting in the FM mode while ready the ecosystem. So when the all the orang kata apa, network yang coverage yang kita determine oleh country itu, so kita capai, contoh dia kalau FM yang sekarang ni kita punya liputan adalah 98%. So kalau untuk digital, so kita make sure kita pun akan dapat similar coverage dan kita boleh fully switch off to the digital radio services. Sebab public service media ni dia punya access, dia concern on those yang uncompromised area tu nantilah. So we need the right to access to information. So kita nak semua orang akan dapat information. So that's why kalau FM switch off altogether tu, make sure that all the ecosystem yang saya mention tadi tu dah terpenuhi lah. Okay.
Kita ada satu soalan untuk Dr. Wan Amir about daripada Nazrul. Do you have a technology on sewer cable robot for cable inspection or installation? Dia nak buat ni lah, cable inspection. Adakah pernah dibuat ke? Development, D&D, design and develop?
Okay, untuk pengalaman saya, pengetahuan saya from my limited knowledge, setakat ni di USM kita tak ada lagi robot untuk sewer cable punya tu. Tapi but then we have this duct punya apa ni, air duct punya robot, the crawler. Robot crawler, some of us build that duct, air duct robot crawler. So might be similar principle lah.
Okay. Maybe kalau Cik Nazrul berminat, dia boleh contact Dr. Wan Amir untuk bincangkan bagaimana projek ni kabel robot untuk kabel inspection boleh dibuat ni. Soalan seterusnya ada kepada ni TS Nurulhusna berkenaan dengan this is about TS Nurulhusna is a research that we are in the implementation of DAB from TS David Chan. So which stage we are now, or is that available for listening now, DAB in Malaysia under the trial?
Actually, we will stop transmitting on the trial from the Menara KL punya location. So currently we are doing some field studies lah during our yearly forum, and also doing a public consultation with MCMC, giving the public consultation information from the public and also from the industry, which or how to implement digital radio. So if you go to the MCMC website now, so there's a public consultation paper. So those party yang interested boleh submit dia punya maklum balas. So saya tak faham, saya kalau tak silap, dia punya tarikh tutup untuk public consultation untuk bagi maklum balas tu adalah pada 31 Oktober tak silap. So kalau ada interested parties yang regarding digital radio punya implementation, so boleh bagi information lah kepada MC. So and we are welcoming any trial and with interested bodies lah, especially kalau macam tadi saya mention on the automotive side kan. So RTM tak ada lagi current trial on the automotive punya sector. So we are welcoming any bodies lah, especially on the retailers, contohnya macam Pioneers kan, dashboard punya receiver, and also macam Mari, so we are welcoming them lah to join the trial with us.
Okay, thanks Nurulhusna. So Nurulhusna has already invited whoever is interested to become to join the project of DAB, maybe come forward, can contact MTFSB. So, or maybe can personally contact Nurulhusna to know how the way to become a broadcasters, or maybe to be a part of a infrastructure team. So this is something that quite interesting, and something that I think Malaysia people is looking forward to have digital radio and to have more stations, maybe dedicated station, small stations, or for local group organizations and like that, or you can contact Nurulhusna for further about that. So there's a questions to Dr. Wan Amir about can we develop smart robotic like human? Wow, this is very scary. I mean, human robot. So is this something that possible to create a smart robot? From TS Muhammad Fauzi, and one more from Muhammad Rizman. This is TS Rizman. Have you tried to cascade several robot module using one controller instead of using separate controller in each robot? So there's two questions for Dr. Wan Amir. Maybe boleh ni ulas sikit, Dr. Wan.
Okey, untuk soalan pertama tadi, smart robotics. Pada pandangan saya mungkin maybe in 20 years time then we will have that. But then kalau tanya saya adakah saya setuju. Saya punya pandangan adalah saya tak setujulah untuk we have this smart robotics which will replace humans. If we watch, suka tengok movie, ada satu movie tu nama iRobots, and satu lagi movie tu kartun nama Wall-E, dan bila kita tengok tu kita rasa kita macam tak ada nilai. Okay. So itu soalan pertama lah. Untuk soalan yang kedua, have you tried to cascade several robotics module using one controller? Cascaded robotics, okay, for the climbing robot, we haven't done it. But from the previous work, we have cascaded the several module of arm robots. Okay, itu saja daripada saya.
Okay, terima kasih Wan Amir. So memang film fiction ni, I mean sometimes really help in the development of technology lah. So we do film first, then we develop the technology later. So yeah, like it's good concept. It's like that. I mean, build the idea from the media and film. Okay, for this is one. I think we take one last question for DAB. Yes, Nurulhusna. Is DAB future proof? I think from Kimpo, DAB future proof. The biggest issue of infrastructure costs. So is this a concern about DAB as a future proof and infrastructure costs? So what is your comment? I mean, to get ROI and to get the government to involve, maybe have some opinion on this? It's mute, T.S. Nurulhusna. Your mic is mute again. Okay.
So let I say in the last two slides, guys. So in order for the DAB rollout to be successful, it must have a financial viability, and it is a future-proof because there are lots of countries are already start using the DAB+, and a new revenue and new services is coming, and we need a full government support for DAB+ in order to success in Malaysia. And adopting DAB+ is low risk in terms of, like you said, the cost for especially the national public broadcasting station, and it is a well-proven technology, and it gives the better benefit to the people. That's my comment.
Okay, thank you, Nurulhusna, for the comment and for me. So I think we are fine. I mean, we are end of the sessions of Q&A. So if you have further questions to ask, you can personally contact our speakers, or maybe you can write email. I mean, to Medialab, so you can convey the message to the speakers. I mean, to answer later. So and again for the slide presentations and knowledge sharing just now, we're going to put at the sharing link, so which you are going to send later to all registered participants for later to view. So please feel free to watch again the talks, and then and then hope from there you can get the knowledge. And first of all, before we end the sessions, I would like to thanks again to both speakers for the great session, for sharing their subject matter expert. Thank you to Dr. Wan Amir, and thank you also to Nurulhusna for spending your time to share knowledge with all technologists and also technicians today. So on behalf of Medialab, so we would like to apologize to all if there is any issues or inconvenience. So, and thanks also to all participants for all the questions, for participation for today's session. So hopefully you guys can join again for the next session on next month, on the first Monday of the month, of every month. So please keep yourself to see the posting on the our website, our FB, so to see for the latest program for the next month. So yeah, and again, thanks again, and then we shall close down our sessions today. So terima kasih, and assalamualaikum warahmatullahi wabarakatuh.
Okay, waalaikumsalam. Thank you, everyone.
Thank you. Thank you, everyone.
Okay.
All around the world.
안녕하세요.
Are you ready to
Thank you.
turn it up?
말레이시아 최고의 라디오를 듣고 있습니다.
Radio station.
Voices Malaysia. We dare to be different.
24 hours a day. Anywhere. Anytime. Non-stop.
Welcome to the family. 감사합니다.